Everyone, how you doing today? Since I can't be there, I am recording lesson 1.4 and hopefully this will make sense. Give me a second while I get set up here to share my iPad screen. All right, there we go. So we're going to skip the review problem and just stick to the heart of the matter for this since it's a recording. Uh, we talked about how one of the main problems of calculus is to find the instantaneous rate of change of a function. And we do that by taking a series of secant lines that are approaching the tangent line. So let's say that this is right here, x, and then we move over a little ways. We'll call it h units. And what we're going to want to do is let h approach 0. That'll move this point closer and closer to this point, and then the secant line would be approaching the tangent line. Notice that the coordinates of this point would be x, and then the y value we get by doing f of x. The coordinates of this point would be x plus h, and then we would get the y value by plugging x plus h into the function. So just basic old slope, difference in y's. So f of x plus h minus f of x over the difference in the x's. So that's the slope of the secant line. I need to let h approach 0 to move that point. Again, move this point closer to this point so that the secant lines approach the tangent line. Well, notice that as h goes to 0, this is just f of x. And then we have f of x minus f of x. And the denominator, as h goes to 0, we have x minus x. So if I try direct substitution, I get 0 over 0. And that's a problem. That is undefined. It's what we call an indeterminate form. Okay, so when you try direct substitution and you get 0 over 0, it's called an indeterminate form. It turns out the slope of the tangent line, I mean, there is one here, right? Like there is a tangent line, there is a slope. We should be able to find it. So this just didn't let us see it. So we need to do something different so we can figure it out. So let's go on down to this specific example of y equals x squared. And we want to find the slope of the tangent line at x equals 2. So we're wanting this, the slope of that tangent line right there. So this is the point 2, 4. This would be the point 2 plus h. And then I would plug 2 plus h into the function, which is just the squared function. So I would have 2 plus h quantity squared. So the slope of the tangent line would be equal to the limit, again, as h goes to 0, because that'll move this point closer to that point, of the slope of the secant line, which is difference in y's over difference in x's. So I just need to find that limit. And it turns out, I mean, if I plug in 0, I'm going to get 0 over 0. It'd be indeterminate. So direct substitution does not work. But if I just use a little bit of algebra, I'm going to square the 2 plus h, and I'm going to get 4 plus 4h plus h squared minus 4 over just h. Well, notice that the 4's cancel, and so I'm just left with The limit as h approaches 0, and that numerator, I can factor out an h. Why did I want to do that? Because those h's will cancel. So now I just have the limit as h approaches 0 of 4 plus h, and direct substitution works on that. I just get 4. If you recall, that's what we got in the past lesson when we looked at using a table of values. We got that the limit was 4. The slope of the tangent line at 2 on y equals x squared is 4. So the focus of today's lesson is going to be, what do we do when we have an indeterminate form? Again, that means we have 0 over 0 when we do direct substitution. And just as I saw a little algebra helped here, a little algebra is going to help us do these problems. There are 4 algebra techniques we're going to talk about. The first one, quite frankly, we just did. It's to multiply out and simplify. So again, if you try plugging in 0 here, you get 5 plus 1. 5 plus 1 is 6. 6 squared is 36. 72 minus 72 is 0 over 0. So I'm just going to square x plus 1. And that gives me 2x squared plus 4x plus 2 as I distribute. Okay, and I need to do some simplifying in that numerator. I have 2x squared plus 4x minus 70 over x minus 5. Let's factor a 2 out of that numerator. I have x squared plus 2x minus 35 over x minus 5. It's looking a little crazy, but hopefully it's going to work out. I need to factor that quadratic. Hopefully you're thinking x plus 7, x minus 5. X minus 5, hey, we have an x minus 5 in the denominator. Notice there was an x minus 5 hidden in that numerator as a factor, and that's what was giving us 0 over 0, which is the indeterminate form. I can cancel those x minus 5s, and I just plug 5 into what I have. So it'd be 2 times 5 plus 7, which is 24 would be my answer. All right, so that's just multiply out and simplify. Algebra trick number 2 is to factor and simplify. We kind of ended up factoring up here, didn't we? But these problems were just starting with the factoring. Do make sure you have an indeterminate form before you start this. Otherwise, you can just plug in. Direct substitution works if it's not 0 over 0. So looking at this, 3 squared, 9, 18. 18 minus 6 minus 12 is 0. 3 minus 3. Yep. Sure enough, that's a 0 over 0 form. So I'm going to want to factor that numerator. And I'm guessing that since there's an x minus 3 in the denominator, there should be an x minus 3 in the numerator, which is going to help me with my factoring. That would have to be 2x plus 4. And checking that, 2x squared, 4x minus 6x minus 12. Yep, that works. X minus 3's cancel. And I just plug 3 in, and I have 2 times 3 plus 4. The answer is 10. All right. Here again, on this problem, if you plug in 2 here, you get 0. 2 here, you get 0. So this is a 0 over 0 form. All right. Do you remember how to factor difference of cubes? Let's hope I do. That's not a 4. That should be a 2. Yeah. X squared plus 2x, I believe. Now give me x cubed minus 2x squared plus 2x squared. Minus 4x plus 4x. Yeah, that works. Over x minus 2. Hey, look, that's what was giving me the 0 over 0. So I just factor that out and cancel it. And so now I just have the limit of x squared plus 2x plus 4, which will equal 4 plus 4 plus 4, which is 12. All right. Algebra trick number 3 is to multiply by the conjugate. You have learned how to do that in order to get things in simplified radical form, which means no square root in the denominator. We are doing the multiplying by the conjugate for a totally different reason here. We actually don't care if we have a radical in the denominator or not. We just want to be able to take the limit. If I plug in 0 here, I get the square root of 9, which is 3 minus 3, hey, 0 and 0. So this is an 0 over 0 form. Here's the trick. Where there's the radical, take the conjugate of that term, multiply top and bottom by that conjugate. This is going to give me a radical in the denominator, but I don't care because my goal is not to do simplified radical form. It's to find the limit. All right, let's see what happens here. When I multiply these, I just get t squared plus 9. Remember, your outside and inside terms will cancel, so we don't have to do them. So we just do our last, and we just get minus 9. Hey, look at that. That's looking like that's going to simplify. The denominator does not look very simplified. Not a whole lot can go on there, but hey, just see what happens here. 9 minus 9. Hey, that's 0. Oh, now I just have t squared in the numerator. Let me rewrite it. Limit as t goes to 0 of t squared over t squared. Well, heck, those t squares are going to cancel. Doop, doop. So I'll just be left. Remember, there's a 1 still in the numerator. 1 over t squared plus 9 square root plus 3. And just plug in. Direct substitution works now. So I get the square root of 9 plus 3, which would be 1/6. That's my answer. All right, let's try one more. Again, if you plug in 0, you get the square root of 7. Oh, excuse me, 9. 9 plus 7 is 16. So we get 4 minus 4. So this is 0 over 0. Remember, if it's not 0 over 0, you can just do direct substitution. All right, so we multiply by the conjugate of the term that has the radical. That just means change that sign in the middle. And let's go ahead and FOIL that numerator. Root x plus 7 times root x plus 7 is x plus 7, minus 4 times 4 is 16. And so the denominator is x minus 9 times the square root of x plus 7 plus 4. Hey, did you see what that numerator is? It's x minus 9. Beautiful. That's what was making it 0 over 0. There was a hidden factor in that numerator. All right, so I have 1 over the square root of x plus 7 plus 4. Direct substitution is going to work now. The square root of 16 plus 4. That'd be 1/8 would be my answer. All right, our last technique, fourth technique, is called simplifying the fraction. So when you have fractions within fractions, that's your clue you want to do this. Fractions within fractions. First of all, make sure you do really have 0 over 0. If you plug in x is 0, you have 1/3 minus 1/3 over 0. So what I like to do is just clear the fractions. So I look at this and I'm like, hey, there's a denominator of 3 plus x and a denominator of 3. If I multiply top and bottom by that, that will clear the denominators. So multiplying this term by this, the 3 plus x's will cancel, and I'll be left with just 3. Multiplying this term by this, the 3's cancel, and I'll be left with 3 plus x. Don't forget we're subtracting that quantity. The denominator would leave me with 3x times 3 plus x. All right, so little simplifying. In the numerator, the 3 minus 3's cancel. I'm just left with negative x. Hey, we can cancel those x's. So I have negative 1 over 3 times 3 plus x. The limit as x goes to 0. I no longer have 0 over 0. I just plug in x is 0, and I end up with negative 1/9. Okay, problem 8. Make sure you have an indeterminate form. 1/4 minus 1/4 over 4 minus 4. Sure enough. The denominators here are 4 and x. I'm going to multiply by 4x over 4x. So 1 over x times 4x leaves me with 4. 1/4 times 4x, the 4's cancels, that leaves me with minus x. So I have x minus 4 times 4x. Notice the 4 minus x and x minus 4 are really close to each other. What I'm going to do is factor a negative 1 out of the numerator. That leaves me with negative 4 plus x, which is x minus 4. Yay! It's the fun part. I get to cancel. Plugging in 4 now, I have negative 1/16. All right, last problem, plugging in 2. 1/2 minus 1/4, not 0. 2 minus 4, not 0. I don't have a problem. Unless, of course, you don't like fractions, then maybe you have a problem. 1/2 minus 1/4 is a fourth. 2 minus 4 is negative 2. So I have 1/4 times negative 1/2, which gives me negative 1/8. That's it. Did not need to use any algebra tricks. Just evaluate, because this is not 0 over 0. Direct substitution works. All right, guys. I hope that was helpful, and I will be back soon. All right, see you guys.